Hello and welcome to the final video in the foundation series, and today we'll be looking at safety for the RSGB foundation exam. As usual, let's have a look at the syllabus and see what we're going to be covering. So the syllabus says 9A, sources of danger, mains power supplies and high current batteries. 9A1 says recall that high voltages carry a risk of electrocution and high currents carry a risk of overheating and fire. Recall why mains powered equipment should have a safety earth. Recall that special care is needed with earthing arrangements if your house has PME. Recall that details of PME earthing can be obtained from the local electricity supply company and are covered in a separate leaflet. And continuing on with 9A, we've got recall that correct fuses must be fitted to all electrical equipment and that this is in the live wire of mains powered equipment and according to the manufacturer's instructions in low voltage equipment. Recall only to work inside equipment that is disconnected from the mains. Recall that the correct way to wire a 3-pin mains plug. Understand the need for a clearly marked switch to turn off all station equipment in case of emergency. 9B says actions to be taken and avoided in the event of an accident. Recall that in the event of an accident involving electricity, the first action is to switch off the power. Recall that the casualty must not be touched unless the power has been switched off. And having a look at 9C, station layout and tidiness. Understand the reasons for not having wires trailing across the floor, trip hazards and the risk of frayed insulation. Recall that elevated wires and antennas must be suitably located and secured. Recall that antennas and feeders should not be sited close to overhead power cables. Recall that antenna erection is potentially hazardous and that it is advisable to have someone to help you. Understand the need for at least one adult to be present. Recall that antenna elements should not be touched whilst transmitting and should be mounted to avoid accidental contact. Note this does not apply to low power devices such as handheld equipment. Recall that particularly high antennas may need special protection against lightning. Safe use of headphones. Recall that excessive volume when wearing headphones can cause damage to hearing. So that's the syllabus items that we need to cover. And as usual, your source of reference, your main source of reference should be Foundation Licensed Now by the RSGB. And you'll find the safety section on page 28 and 29. And at foundation level, the emphasis is on avoidance of risk, not the skills for working on live equipment. So as a general rule, you should not work on live equipment. So, some effects of electric shock. This isn't in the syllabus, but is, if you like, a bit of background information to aid understanding. So, neurological effects, ventricular fibrillation, and burns, including internal burns. So, electric shocks are quite serious, and of course, electrocution can lead to death. So, it's a subject we should all take quite seriously, particularly if we're dabbling in items that use electricity. Now, it is the current flowing through the body that does the damage. So we have a saying, volts jolt, but mills kill. And that saying is that voltages make you jump, but it's the milliamps flowing through your body that kill you. Volts jolt, but mills kill. And it is said, I think, that as little as 30 milliamps flowing through a body can, in certain circumstances, lead to death. So very small currents flowing through a body can lead to death. or damage to organs or the body in general. But you've got to remember that the voltage drives the current. So high voltages are therefore dangerous. You recall, I think, from the Ohm's Law Foundation video, the little graphic with Mr. Volts pushing Mr. Amps across along a wire, and Mr. R, Mr. Resistance, trying to squeeze off the flow of current. So the voltage is pushing the current along, and the resistance is trying to inhibit the current. So if voltage drives current, then it follows that high voltages are inherently more dangerous than low voltages for electrocution. And sources capable of delivering high currents are more dangerous than sources that are current limited. So if you have a source like the mains, which is really not current limited, it'll give you as much current as you want to draw from it, it's pretty dangerous. But if you have a sparking plug on a car, although the voltage is high, if you touch it, you should probably only get a nasty jolt enough to make you snatch your hand away, because the current behind it, if you like, its ability to deliver current is quite low. So volts jolt, but mils kill. So let's have a think about electrical wiring. So all the items ought to be earthed, and Radio Shacks ought to be protected by RCD earth trips. Only items which have double insulation need not be earthed. Quite a few consumer items these days have double insulation. They can include things like power supplies for computers, wall-wart type ones, and other items, perhaps hairdryers with double insulated housings. And because the double insulation is there, they need not be earthed. But all other items, any item with a metal casing, needs to be earthed. You need to have a single well-marked off switch in the shack for all power. This is so that if there is an accident, there's a single place to go to switch off all the power for the shack. If you are rescuing somebody, do not touch a casualty unless you are sure the power is off, else you will become a casualty yourself. So if they are still connected to the electrical supply and you touch them, you will conduct the electricity that is going through them, and then you will be a casualty yourself and therefore unable to help them. Now we're going to dig in a little bit about why we need earths here, and this goes beyond what we need to know, but it perhaps will help us to visualize what's going on. So if we have a power supply such as the one shown in the shack, and if we plug it in and switch it on, then it'll operate with the little red light showing on the on-off switch on the front, and everything is as it should be. Now if we are going to work on this at all, if we're going to take the covers off, we must unplug it. And here we have unplugged it, but now we're going to assume that it's in an operational state just for illustrative purposes. But practically speaking, if we were to work on it, we must physically unplug it. It is not sufficient simply to switch it off at the wall. And the reason for this is that if there's any miswiring in the wall socket, for example, the positive and the neutral, the live and the neutral, I beg your pardon, were inadvertently swapped, then in fact it wouldn't be off properly with the switch on the wall. So you need to physically unplug the equipment if you're going to work on it. Also, if it is a power supply, you need to leave it for a period of time so that any charged up capacitors inside have a chance to discharge. So avoid working on mains powered equipment unless you know what you're doing. Always unplug and switch off before removing covers. So let's have a look at the operation of this one. If we take off the front panel there and we take off the enclosure, inside there is a simplified depiction of what's inside. We've got the the live wire coming in from the mains, and it's going through the on-off switch. And then out of the on-off switch it goes to the primary winding of a transformer. And the other end of the winding then returns back on the blue neutral lead to the plug, and the earth lead of the plug is connected to the case with a lug and a screw perhaps. Secondary winding of the transformer is connected to the electronics, but we're not looking into the detail of the electronics. I've just depicted it there as a single circuit board. So this is what is going on electrically. If we follow the current, the red dot then on the plug, and we follow it through, the current flows down the brown live wire, through the switch, through the winding, and returns on the neutral. And the current is well within the tolerance of the fuse. Perhaps it's a 3 amp fuse, and the fuse is protecting the equipment. If the current exceeds is more than 3 amps, then the fuse will blow, and then the live will be disconnected. Let's see a fault condition. Let's imagine that the lead out of the switch becomes disconnected and touches the case. Now the case is now live, and let's follow the current. The current then flows down the brown live wire onto the case, back through the case, and now it comes back through the earth lead and goes to earth. And looking at the fuse, because the current is now unlimited, if you like, there's nothing stopping it flowing from live to earth, the fuse blows and the equipment is now offline, and then it's become safe. And that is thanks to the earth. Let's have a look and see what would happen if we didn't have the earth connected. And in this graphic here, we've disconnected the earth. We only have at the plug the live and the neutral connected. And let's have a look at the effect of somebody now touching the case. Remember that the live is supplying power through the switch, and it is now going to the case, but now it comes back through the person and they're electrocuted. It could no longer return through the earth because the earth is disconnected. Let's have a look at that again. The current flows down the brown wire, the live, onto the case, and then back through the person, electrocuting them. Now the person is electrocuted despite the fuse, and the fuse hasn't blown. The reason is that the person is fairly high resistance, and so not enough current flows to blow the fuse, but enough current flows to kill the person. The fuse may be rated at 3 amps, but we said that only about 30 milliamps is needed to kill the person. So only 1/100th of the fuse capacity is needed to kill the person. So the fuse is not there to protect the person directly, it's there to protect the equipment, thereby protecting the person. So if any fault current flows, it blows, but it does rely on the earth being connected. And for this reason, you should always make sure that any metal cases are indeed properly connected through to the earth pin of the 13 amp plug. And you can use a continuity tester or several other methods to do that. As I say, this is beyond the scope of the foundation course, but it's giving you some background. Now here we have a more dangerous fault because the wire leading to the switch has touched the case, and as the case is then live even when the equipment is switched off. So you can see the brown lead coming into the switch this time has fallen off and it has touched the case. And you might consider that the equipment was off, it was safe, but it is not, because the live is now connected to the case, and as the earth is not connected, we have a very dangerous situation. So I think that highlights the requirement and the need to have proper earths, proper safety earths. So let's have a look at another situation. Here is a woman who is touching a Van de Graaff generator which is generating 2 megavolts, and it's charged up her hair such that the similar particles in her hair repel each other and it frizzles out. So why is this woman not electrocuted when she touches 2 megavolts? Well, the answer is she's on a thick insulating mat, probably a rubber mat or similar, and there is no path for the current to flow. Remember, volts jolt but mils kill. And in this case, there's no circuit complete for the current to flow through, and that's due to the black insulating mat that she's standing on. However, if she steps off the mat onto the floor, then the current then flows through her body down to earth or the floor, and her hair catches fire and she's electrocuted. So this indicates one of the safety features that you can have in your shack, at your workbench or similar. You can put your chair on a rubber mat. That will also be good in case of accidents. It will stop the current flowing to earth as easily. Now, headphones may enhance the effect of an electric shock. Not directly a syllabus item, but it is mentioned in Foundation License now, so I thought we'd cover it here. Here we have a man who's touching the live wire of a 13-amp plug, and the current flows through his body to earth, showing it flowing through his heart there, which is serious enough. If he's lucky, it might go down the other leg and avoid his heart, but that's the path that it might take. He would be standing perhaps on rubber-soled shoes, maybe on a carpet, and so not necessarily a great path to earth, and he may well survive. If he puts on headphones, however, the lead and the headphones may be close to earth, and it's a bit like clamping an electrode on your head. And so here we have the path there going through, frying his brain, which is obviously very, very dangerous. So in the Foundation License Now book, it says that headphones can exacerbate the effect of electrocution. Another item we have to look at is high current batteries or high current sources in general. And if you look at the battery depicted there, you can see that the maximum current is 680 amps. Now that's a massive current, and these batteries need to generate massive currents in order to crank the electric motors in cars to get them to start. So that's the maximum current, and if you multiply the current times the voltage, the power is instantaneous power can be 8 kilowatts, or more than 8 kilowatts. And that would be like having 8 of the old style bar fires all producing power at the same time. So a considerable amount of power can be produced instantaneously from a battery such as this one. If we have a spanner, we take the protective covers off the terminals of the battery, and we drop the spanner across the battery inadvertently, then the lead would probably spit out from the pillars of the battery, and the tool itself may become molten and melt. Or if it's wire, then the wire would get so hot the insulation may catch fire. And this can cause severe injuries. Here's a burn injury from high current electrical accident. Now, even small cells or batteries, we call them batteries, but they're essentially cells, can start fires. And there's a classic one of the 9-volt battery and a piece of steel wool, and if you push them together, the steel wool will catch fire. Because even small batteries like that can give several amps of instantaneous current in short circuit condition. won't last very long, but they'll last long enough to start a fire. So then, summarising, with high current, supplies capable of delivering high current pose a risk even if low voltages are present. A short circuit or too low a resistance can result in high currents which can overheat wires and start a fire or cause burns. Even smaller batteries, e.g. rechargeable batteries, can cause surprisingly high currents and cause wires to become red hot. Batteries have internal resistance, so a short on the rechargeable battery may cause the battery itself to catch fire. And when working on electrical equipment, rings and wristwatches should be removed. That is because they can provide that very short circuit. And there is a picture of somebody's hand, and the ring has vaporized as they've touched it across a high current source. They seem to have been very lucky in as much as they seem to be minimally injured. If you look on the internet, you'll see far more gruesome pictures than that. So remove rings and watches if you're working on equipment where there could be a potentially high current. Safety earthing. Ensure shack equipment is run from a common mains earth to prevent earth loops. Use filtered mains boards and ferrite rings correctly. That's because the safety earth might be a bit noisy, and you may wish to put ferrite rings around the earth to reduce the electrical noise. But it's important that you don't interrupt the electrical continuity of the earth. Modern plastic, gas and water pipes give high resistance earths. So it's no good thinking that there's a good earth because there's a piece of copper pipe, because that copper pipe might transit through to PVC or alkathene, and although you have the impression you've got a good earth, you haven't. Beware of some house earths floating above Earth's potential. Although the electricity companies should keep neutral close to Earth, you can't absolutely guarantee it. So don't automatically think that the neutral is going to be safe. And most importantly, do not mix mains earth, which is for safety and is what we've been discussing, with RF earths, which are for antennas and which are there to conduct RF to earth. In any case, mains earths are electrically noisy. This is because things like washing machines and other inductive loads are connected to the earth and end up putting electrical noise on the earth. And you don't want that on your RF earth. Now, a very important subject is PME, or protective multiple earth. PME is being increasingly installed, especially in new builds, and it affects the manner by which devices are earthed via the mains supply. Special care is needed on earthing arrangement to avoid risks in PME fault situations. If you have PME, you must consult a suitably qualified electrician before fitting an RF earth. I'll just say that again. If you have PME, you must consult a suitably qualified electrician before fitting an RF earth. Under certain fault conditions, on the PME system itself, your RF earth can end up taking the whole street's earth current, and that could cause a fire or electrocution. And a leaflet is available from the RSGB, and there it is, and that can be downloaded from the RSGB site if you wish to have greater understanding. But if you have PME, you must consult a suitably qualified electrician before fitting an RF earth. Let's move on to mains plugs. There's a picture of a mains plug, and I think most people will be familiar with the layout and the fitting of a mains plug. It's worth saying that in the intermediate practicals, one of the tasks is to correctly fit a mains plug. And you should know that the neutral is blue, the earth is yellow and green, and the live is brown. And you should know that the live is the fused lead there. You can see it goes through a fuse before going into the pin. The Earth is in the centre, and on the left is the neutral blue. So avoid whiskers, trapped wires, and ensure that cord grips are secure but don't pierce the insulation. So the cord grip is there to stop the cord pulling out and then pulling on the electrical connections and having them disconnect. Some people like to make sure that the earth, if they do disconnect from being pulled out, that the earth is the last one to disconnect, that the live is the first one to disconnect, the neutral second, and the earth third. And you do this by having a little bit of an extra twist, a little bit of an extra loop, if you like, in the earth, so it's the last one to be disconnected if somehow the cord is wrenched out of the plug. Fuses are to protect the equipment. Low power devices must be correctly fused at 3 amp or 5 amp. In other words, you don't always have to have a 13 amp fuse in. You should have the lowest fuse consistent with correct operation of the equipment. That's because you want the fuse to blow at the first sign of trouble in the equipment. You don't want the equipment to start to melt inside before enough current between the live and the neutral is flowing that the fuse blows. So for a transistor radio, for example, 3 amps would be a lot of power generated and dissipated in fault conditions, but less than if you had it in a 13 amp fuse. Faults aren't always shorts. A fault may not blow a large fuse, but may overheat a flex and cause overheating or fires. So you may have a partial short or low resistance and a 13 amp fuse, for example, and in the flex may just get very, very hot because it's carrying, let's say, 12 amps, or the equipment itself may be dissipating quite a few kilowatts of energy, but the fuse hasn't blown. So faults aren't always shorts. A fault may not blow a large fuse, but may overheat a flex and cause overheating or fires. Be alert for fraying or damaged insulation on mains leads. Let's go on to headphone and ear damage. So here we have a chap in his shack listening to his headphones. And it's the nature of HF, and in fact radio in general, that when you're tuning up and down, you may suddenly come across a large or a high-level signal, or thunderstorms or atmospheric noise may cause crackles and crashes. And if that happens, then you might suddenly get a loud noise in your headphones, which can be painful and potentially damage your hearing. So if you look at Foundation now, it gives you hints on how to prevent this happening by tuning from setting the volume low in the beginning and turning it up till you hear the signal, not vice versa. Other hazards are mentioned in the book: sharp or hot tools, like knives, screwdrivers, saws, etc., and hot tools like soldering irons. Trailing or overhanging wires. There are obvious trip hazards or hazards associated with those. And look out for frayed wires, particularly those under carpets or rugs, because these may cause fires or electric shocks, because the fraying will be unnoticed because they are being walked on, but under the carpet. Indoors, you should have a tidy shack, avoid trailing mains leads on the shack floor and other trip hazards. Headphones, be aware that excessive use to pick out weak signals from background noise can damage hearing. Allow time for power supplies to fully discharge after switching off. So the smoothing capacitors in power supplies will quite often hold the charge for a considerable amount of time. Lightning, disconnect your antennas, protect your radios from static charges. So if you have thunderstorms passing through, disconnect your antennas. Outdoors, ladders, take care when erecting ladders, etc., and when erecting an antenna at height, an adult should be present. Lightning, high antennas may need special protection. Antenna elements should not be touched when transmitting and should be mounted to avoid accidental contact, particularly by other people. Keep clear of overhead power lines and snagging or coupling into telephone lines. So here, the coupling into telephone lines comes from the EMC part of the syllabus, and what they're saying is don't run a long dipole or long wire in parallel with a telephone line if you can possibly avoid it, because you may couple your RF energy into the telephone line and cause problems. Keep clear of overhead power lines, because the last thing you want is your antenna mixing with overhead power lines, because that will create an electrocution risk in the shack. Also, with overhead power lines, look out when carrying ladders around in case you touch the overhead power lines and electrocute yourself. Feeders and antennas must be soundly fixed in case of being accidentally pulled, high winds, icing, or bird strikes. So there we are. Don't mount antennas up high with flimsy fittings, because if somebody accidentally pulls the feeder, they may pull the antenna down on top of themselves, with that consequent risk. So let's have a quick look at RF burns. RF burns, these are electric shocks from feeders and antennas, and because they are RF, they can be particularly deep. They will be less of a problem at the powers allowed for the foundation license, but become more of a problem as you go up through intermediate and full licenses. Make sure that antennas and exposed feeders cannot be accidentally touched, and of course that is particularly by others who may not even be aware that these feeders and antennas are live. And there is a picture there of a small RF burn on a finger, and you can see it's made a little pit, which is the typical shape of an RF burn on a finger. Obviously, high-powered RF burns are considerably worse. So I think that just about covers it. We'll whip through the syllabus to make sure. Recall that high voltages carry a risk of electrocution, and high currents carry a risk of overheating and fire. We said volts jolt, but mils kill. So the high voltages drive a small current through the high resistance body, and that is electrocution. And high currents, like from the battery or from mains, can cause a risk of overheating and fire. High currents flowing through conductors generate a lot of heat, and this can be quite dangerous. Recall why mains powered equipment should have a safety earth. If you don't have a safety earth on it, then the fuse has no chance of blowing. If there is a fault whereby the live becomes contacted with the case, or if there's an internal fault such that the equipment draws too much current, you want the fuse to blow and therefore disconnect the live from the equipment. Recall that special care is needed when earthing arrangements, if your house has PME. Recall that details of PME earthing can be obtained from the local electricity supply company and are covered in a separate leaflet. So there is a leaflet from the RSGB, and that is a very important thing to take on board, because the RF earth can end up taking considerable amounts of current with a consequent fire and electrocution risk. So you need to understand, or at least have somebody that does understand PME tell you what the correct arrangements are. Recall that the correct fuses must be fitted to all electrical equipment, and that this is in the live wire of mains powered equipment and according to the manufacturer's instructions in low voltage equipment. In some cases, it's not always in the live wire. That is in some DC equipment, perhaps sometimes fitted to cars and things like that. So you need to follow the manufacturer's instructions for low voltage equipment. But correct fuses must be fitted to all electrical equipment, and that this is in the live wire for mains powered equipment. And here we're saying don't use a 13 amp fuse when a 3 amp fuse will do. You need to have a fuse that is able to carry the current needed for the correct operation of the equipment, but not overdo it such that fault current won't blow the fuse in good time. Recall only to work inside equipment that is disconnected from the mains. So it's not enough simply to switch off the main switch on the wall. You must disconnect the equipment from the mains. And there's a couple of reasons for this. One is that the neutral may not be the neutral. It may not be close to Earth, which you should expect, but also because the neutral and live may have become transposed in the wall socket by mistake, maybe a poor installation or something like that. And although you think you've switched off the live, you've actually switched off the neutral, and the equipment is still dangerous. So you must unplug it. You must disconnect it from the mains. Recall the correct way to wire a 3-pin mains plug. You'll find a diagram also on the inside back cover of Foundation Now, but also in this video the same drawing. Understand the need for a clearly marked switch to turn off all station equipment in case of emergency, and you should advise other house members if they come into your shack and find you lying on the floor as a result of electrocution, so that they don't get hurt. They need to be able to switch off all of the electricity with that single breaker and then be able to assist you. Actions to be taken and avoided in the event of an accident. Recall that in the event of an accident involving electricity, the first action is to switch off the power. So we've covered that from the main switch. If you're in another situation and there isn't a main switch, then you need to unplug the equipment that the person is connected to, or by other means make sure that the victim is not still connected to the electricity. Recall that the casualty must not be touched unless the power has been switched off. And station layout and tidiness. Understand the reasons for not having wires trailing across the floor, trip hazards, and the risk of frayed insulation. And we said particularly under carpets. Recall that elevated wires and antennas must be suitably located and secured, not only for yourself, but for other people, so that anybody walking along won't find themselves walking into a feeder sort of hanging at an inappropriate height or something like that. Recall that antennas and feeders should not be sited close to overhead power cables. This is in case either the power cable drops onto the feeder or the antenna or feeder blows up onto the power cable, as this could cause an electrocution risk in the shack. Recall that antenna erection is potentially hazardous and that it is advisable to have someone to help you. So you shouldn't do it alone in case you do fall off the ladder, and you may need somebody to help you hold the ladder, and you should recognize that it is potentially hazardous because you will be working at height. Understand the need for at least one adult to be present. Obviously this is aimed at juniors, but is a very important syllabus item. Recall that antenna elements should not be touched while transmitting and should be mounted to avoid accidental contact. Now, if you're out at a show or something like that and you've erected some antennas, make sure you tape off the area with hazard tape and mount them sufficiently up in the air so that people don't accidentally touch them, because people don't always recognize that an aerial is for a transmitter as well as a receiver, and may think it's quite okay to touch it. So this obviously doesn't apply to low power devices such as handheld equipment. The power is such that, similar to a mobile phone, it doesn't present a hazard. Recall that particularly high antennas may need special protection against lightning. Now, you don't need to know any details for this, but if you have an antenna which is above all of the roof lines and perhaps is potentially going to act a bit like a lightning rod, then you may need to have some special protection installed, but you don't have to say what it is. Safe use of headphones. Well, we covered the electric shock implications of headphones, although I don't see them in the syllabus. They are covered in Foundation Now. But 9D1 says recall that excessive volume when wearing headphones can cause damage to hearing. So thank you very much for listening. This is the last video in the Foundation series. and this series will be updated in due course in accordance with the new syllabus that is being which has been published but not brought into effect as far as exams go by the RSGB. So once again, thank you very much for listening from the Cornish Radio Amateur Club 73s.